Welcome to our latest instructional video. They are covering topics in Alberta's Math 7, although the topics can appear in other program levels in other areas. Today we are looking at absolute values. We're going to start with our curricular outcomes, define what absolute values are, and then take a look at some examples calculating with them. So first, our outcomes. Our organizing idea is that numbers are organized into systems with unique notation to communicate quantities and to facilitate calculations. Our guiding question is, how could the symmetry of the number line contribute to a sense of number? Our learning outcome is that students will analyze positive and negative numbers. And our key understanding is that every fraction and decimal number has an additive inverse with the same absolute value and opposite sign. We're going to talk about absolute values today. Additive inverse is whatever you add to that number to get 0 as an answer. So for 3, additive inverse is -3. For -3, the additive inverse is +3. Today's specific skill, finding and using absolute values. We're going to relate the absolute value of positive and negative numbers, including decimal numbers and fractions, to their positions on the number line. Let's start by defining what absolute values are. So a useful quantity in mathematics is the absolute value of a number. This is represented by vertical lines around the variable or number. For example, the absolute value of x is written with vertical lines before and after the letter x. The absolute value is the distance between a number and 0, and distances are always considered positive. So positive numbers are unchanged. The absolute value of 5 is 5 because it's 5 units away from 0. 17 is 17 units away from 0, so the absolute value of 17 is 17. Negative numbers become positive. -5 is 5 units away from 0, so the absolute value of -5 is +5. -17 is 17 units away from 0, so the absolute value of -17 is a +17. Now, when you have more complicated things inside those bars, you calculate everything inside before applying the absolute values. So the correct way to calculate 2 minus 7, or the absolute value of 2 minus 7, I should say. 2 minus 7 is -5. We do that first. The absolute value of -5 is +5. A common trap that you do not want to fall into is to say, well, 2 minus 7, you do the absolute value of -7 to make that positive and end up with 9. Okay, this is not the case. You do not apply the absolute value first. You do it last. Some examples, and I apologize for the air conditioner that just kicked in. You'll probably hear the hum in the background. So first, calculate the absolute value of 32. Well, it's a positive number, so it's not going to change. The absolute value of 32 is 32. Now the absolute value of -63/17. That's an improper fraction. That's 63/17 units away from 0. It's just negative. So the distance from 0 is 63/17. The absolute value of -63/17 is +63/17. We just dropped the negative. For single numbers inside, it really is that simple. Positives don't change, negatives become positive. Calculating 8 times 0.2 minus 5. That's a little more complicated. We do what's inside first, following order of operations. 0.2 minus 5 is a -4.8. 8 times a -4.8 is a -38.4. Now we have a single number. Now we apply the absolute values. The absolute value of -38.4 is +38.4. Let's take a look at the absolute value of 5.8. The number 5.8 is positive, so the absolute value of 5.8 is Take your time. You should not need this much time. 5.8. Let's calculate the absolute value of negative 1701. The number negative 1701. It is obviously negative, so the absolute value is the positive number, or 1701. Let's calculate negative 0.9 times 13 minus 4. Well, we always do the calculations inside following order of operations, so we start with the brackets. 13 minus 4 is 9. Negative 0.9 times 9 is a negative 8.1. Absolute value of that is positive 8.1. So those are our guided examples, our we do problems. Now you do. We have 3 numbers here. Pause the video, take as much time as you need. I hope you've got at least the first 2 done by now. The absolute value of 83 is 83. The absolute value of negative 12.9 is 12.9. This one is a little more complicated. We work out what's in our brackets first because we do all the calculations inside. So 3 minus 1 is 2. 1 plus 4 is 5. 4 times 2 is 8. 7 times 5 is 35. 8 minus 35 is a negative 27. And the absolute value of negative 27 is positive 27. So if you have any questions, any feedback about this or other lessons, please feel free to drop them in the comments. That's students trying to understand the material or asking for further clarification on the slides and the content. Teachers, if you have feedback how I can make these slides better, I would appreciate that too. Just let me know and I will do my best to respond in a timely fashion.